In this lesson, we'll be learning how to read someone's measurement and figure out how many significant digits are in the measurement. First, let's go over the rules for what's a significant digit and what isn't. A significant figure is any part of a number that was actually measured, including the estimated digit. Now, non-zero numbers are always measured numbers, and so they are always going to be significant. Let's look at the examples that we have here. In the first example, there are 5 numbers that are non-zeros, and all of them are significant. In the second one, there are 3 values that are non-zero, and so there are 3 significant digits. Now that we know what to do with non-zero numbers, that they're always significant, let's talk about the zeros. Now, zeros have different placements within a number. I have a number written here, and there are actually a couple different kinds of zeros. There are zeros that are out in front of a number. There's a 0 that is in the middle of a number, and then there is a 0 at the end. And in this lesson, we're going to call those leading zeros. So that would be any 0 that is out in front of a number. Any 0 that is in the middle of a number, so between 2 non-zero numbers, we're going to call those sandwiched, or sometimes we call them captive zeros, like held captive between 2 numbers. And then the ones that are on the end are called trailing zeros. Now let's talk about each one of these types of zeros one at a time. The first one are these leading zeros. Now, leading zeros only exist to make a number smaller, and so they aren't actually measured, and therefore they are never going to be significant. So when we look at our example here, it has 3 numbers that are non-zero, so we know it has at least 3 significant figures. And when we consider the zeros, they are all leading zeros. None of them are significant, and so this number only has 3 sig figs, just the ones that came from the non-zero numbers. Now let's talk about the sandwiched or captive zeros. Captive or sandwiched zeros are always between 2 non-zero numbers, and because they have a measured number after them, they themselves are going to be measured. And so sandwiched zeros are always significant figures. When we look at the examples that we have here, in our first example, this one is a leading zero, so it's not going to be significant. The 6 is a significant figure, the 7 is a significant figure, the 0 between the 7 and the 8 is significant because it's a sandwich 0, and the 8 is a significant figure. So this one will have 4 sig figs. In our second example, the 1 is a significant figure, and these next 2 zeros are sandwiched zeros, so they are going to be significant. The 1's non-zero, so that's going to be significant. And then we have some more sandwich zeros and also the 8. So this one has a lot of sig figs. It has 1, 2, 3, 4, 5, 6, 7. Now let's talk about our last type of zero, which are the trailing zeros. Now, trailing zeros can be measured, but they can also just be there to give magnitude to the number. And let's look at these 2 examples that we have. In the top number, these zeros are measured, and we know that because there's a decimal point. In the bottom example, those zeros were not measured, and they only exist to give this number magnitude. And what I mean by that is to make the number have the value of 1,000 instead of 10 or 1 or 100. It has those 3 zeros to give it the magnitude of 1,000. Now, the easiest way to know if trailing zeros are significant or not is by looking for that decimal point. If there's a decimal point in the number, the trailing zeros are going to be significant. If there's no decimal point, they are not going to be significant. Now that we've covered our zeros, there is one more type of number that you might come across in your calculations, and that is exact numbers. Exact numbers are pretty few and far between, They come from counting, which we don't do very often in science, just count things, and also definitions. Now, exact numbers are things that have infinite number of significant figures. So they are never going to limit our significant figures and calculations in any way. Now that we know the rules, let's get some practice. I've listed most of the rules right up here, and let's use those rules to figure out how many significant figures each one of these measurements has. Now for this first number, there are 1, 2, 3 non-zero numbers. Those are always significant. And then it has a 0, that is a trailing 0. For trailing zeros, if there's a decimal point, it's significant, and there is a decimal point here, so that one is significant, and it has 4 sig figs. Now for the next number, it's similar. It has non-zero integers. So for this number, there are 1, 2, 3 non-zero integers, so it has at least 3 sig figs. But now we have to talk about this trailing 0. For trailing zeros with no decimal point written, that means that the 0 is probably not a significant figure. It's a little ambiguous, and we don't usually write numbers like this that have non-significant zeros at the end, but if there's no decimal, we would consider that not to be a sig fig. So this would be not a significant figure, and this would have 3 sig figs. Now the second part of this is that it is best to use scientific notation in numbers like this. Instead of writing the number how I did, 1, 2, 3, 0, it would be better and leave people wondering about whether you really mean that that's a significant figure or not. It would be better to write this in scientific notation, which would be 1.23 times 10 to the third. And you're being very specific about your sig figs there. This has 3 sig figs. There's no ambiguity around that 0 being there or not. Okay, let's talk about C here. In C, there are 1, 2, 3 non-zero numbers, and then there is a sandwich zeros, and those are always significant. So this one has 4 sig figs. And on the next one, there are 3 non-zero numbers, and then these are all leading zeros. Leading zeros are never significant, so none of these are going to be significant figures, and this only has 3 sig figs. And for our last one, E here, it has non-zero numbers, so there's at least 3 sig figs, and then it has a trailing 0. Notice that there is a decimal point there, and so for trailing zeros, it has a decimal point. Those are going to be significant. So this one will also be significant. That has 4 sig figs. Now it is a little awkward to have that 0 and the decimal point at the end here, because it makes it really seem like you should put another one there. That is not what we want to do. Again, in situations like this where you're trying to make a trailing 0 significant or not, the best way is to write it in scientific notation, and the way that we would do that here would be 1.23, and we want that 0 to be significant, so we would put the 0 there, times 10 to the 3. So again, this has 4 sig figs, just like our number here did. But the 0 and the decimal point aren't at the very end there, and it doesn't look as weird. So scientific notation can be used to make that look less awkward and to make that trailing 0 significant. And now we've learned how to figure out how many sig figs a number has.